I'm Indu Peddibhotla, VP Product Management at Commvault. I want to start off with how does an attack progress through a customer's environment? Kind of start with that, and then we'll dig into some of the details. When a bad actor or a threat gets into a customer's environment, the first thing they try to get in is access to a system, right? And then once they get access, they try to establish a command and control back to some mothership that they have that can send commands into customer's environment. And then they're also trying to spread laterally, trying to do recon, trying to find information, where are the critical assets, the crown jewels that Isabel talked about. And they're also trying to find those privileged accounts and escalate their privileges so that they can get access to those critical assets. And oftentimes, when we talk about ransomware, we just talk about encryption of the data. But in reality, there are other ways of how these threats can impact customers. There could be leakage of data, which is an accidental leak of critical data. There could be ethical hackers who are taking the data and posting it in public sites. And there could be some stealing of data for espionage or whatever other mechanisms, or to sell it into the third-party black markets. So there's this constant pressure on customers to protect their data, protect their environments. And this is really where our ThreatWise launch with the TrapX acquisition really moves the needle for our customers. And Isabel talked about how it's differentiated. It's differentiated because not only are we helping customers recover the data post the breach, which is where most of the data protection vendors are playing, but we actually, in a ways, are shifting left and being more proactive, coming up with those early warning detection signals that customers can use to get those initial warning that they're under attack. And as most of us know, the sooner those attacks are identified, the sooner they can be contained and sooner they can be mitigated. So this is again, how the attack kind of progresses through. And in terms of, the time it takes for the attack to propagate, I mean, we've got very sophisticated threats in play now. And within 2 hours of getting into a system, they can do a lot of damage to customers' environment. It again reinforces the need for customers to be able to have those early warning signals, to be able to detect this as early as possible, right? And that's where, in terms of detecting, responding, and containing, the early detection kind of comes into play. And the sooner they can, with systems like ThreatWise, they can get those early warning signals that can help them take the necessary actions.
Going to some recent threat, ransomware have been in place for what seems like months and stuff like that. They've kind of served, slowly but surely kind of infiltrated their environment and stuff like that. I haven't seen anything that went from 2 hours from infiltration till, threat.
Yeah, I mean, you're right. There's all kinds of attacks out there. Some of them are dormant, kind of doing recon for a number of days before they start making their move. And really what we're trying to protect is as soon as they're trying to make a move, trying to either move laterally or trying to kind of find those critical assets, that's where ThreatWise comes into play, where we can catch those bad actors as they're progressing through this. And we're going to show this as well as part of the demo. The technology can actually detect what phase of the attack the threat is in. So we have a mapping to MITRE ATT&CK framework. MITRE ATT&CK is a popular framework. It kind of talks about how the attack progresses. So we can detect those phases and help customers identify them, whether are they in a recon phase? Are they in a are they in a phase where they're trying to move laterally, and so on. So you're right. Some of the attacks kind of take longer, and then they stay dormant while they're kind of figuring things out. But our goal is to help customers in our data protection mission to find, as soon as these threats or whatever malware is gotten into the environment, tries to make a move, try to identify those actions and help customers detect those early.
I know we may probably already go into the demo piece and we'll cover it, but the first thing that comes up is how. Is it going to be capturing at the network, capturing at the endpoint, sitting on the file? the immediate thing, I appreciate that it's just not a person in the balaclava, that's just a guy with a hoodie on. We're closer on describing the bad actors. You should just put William Shatner there. But when it comes to the how, there's a lot of questions.
Yeah,
And so
sure you have.
a lot of these things are coming in as 0-day activities, and it's never been discovered before. And how are you going to be able to understand that the threat is active?
Right. So yeah, we'll get into those details. So the intent really is to put in these decoys or sensors that we call within a customer's environment, right? That look and feel like real assets, that behave like real assets. So any threat that's kind of, for example, when it gets in, let's say they do a scan of the network to figure out, okay, where are all the different systems that I can then get into, right? And with ThreatWise, we can deploy these sensors that look like they're production assets. And this is where customers or these threats kind of trip over. And they're like landmines that what they do is as soon as any interaction happens with these sensors, they flare up, right? So the moment somebody does a network scan, the moment somebody tries to reach out to this asset that looks like a real asset, in the back end, the systems are alerting, flaring up. And two, they can also engage with this attacker. They can present them responses as they are asking some questions or trying to figure out what data is in there. So we can keep engaging with them. So it delays their, the way threats propagate. And then thirdly, it's also increasing the surface area for the attacker. So, right, versus having X number of real assets, now we have introduced Y number of additional fake assets that for all practical purposes look like real assets.
Now, with these honeypot type of assets, just I'm going with the old school name of it because that's ultimately what it is. If something were to go in, as I said, like a 0-day or a botnet style of implementation, and you want to, like the first thing you would think is a system should immediately become immutable and then hold that signature, understand that heuristic, and then ultimately report. But you say that this asset basically going to keep living in this network. What is around this honeypot that keeps it from allowing that thing to spread as it's meant to?
Yeah. So look, I mean, we are an augmentation to the security tools that are out there in customers' environment, right? And we play into the security ecosystem. So all the signals that we generate, we also send them to third-party systems like Splunk or whatever SIEM or other security monitoring systems that customers are using. And our customers, some of TrapX customers as well, have written playbooks around, like, if they see an event coming from TrapX and ThreatWise into this security tool, here's a playbook for you. We know the source IP of where it's coming from. We know the host, and systems like Carbon Black and others can isolate those source information. So that's a playbook dependency that we have on the third-party security system. And our goal is, we're arming them with all the information that they need to take action and create those runbooks and playbooks.
So if you're going to cover this in the demo, just tell me, and I can wait. But what do these threat signals look like? What are they composed of? And
I understand we'll walk through that. We'll show you how an actual event looks like. Okay. And we can double click into that. It contains the source information. It contains what type of, where we kind of think we map this interaction to in the MITRE framework. We'll show you what sensor they're connecting to and the type of interactions they're doing.
It might be more sense and context. Okay.
Yeah. And one important thing to note here, right, is when we talk to our TrapX customers, existing customers, and the new customers that are using and leveraging ThreatWise, one of the key things they point out is customers do these red teaming exercises or pen testing exercises. And oftentimes, ThreatWise is one tool that always lights up immediately. I mean, there's a lot of security tooling out there in customers' environment. There's a lot of noise out there. And oftentimes, these admins and security admins or operations teams are inundated with all these events coming in. For them to figure out which is real, which is like a false alarm, is extremely difficult. And what ThreatWise, because the nature of how we deploy these sensors and the fact that they are not in the production flow, so any real application should not be using them. we can whitelist if there are services in a customer environment that is doing scans and stuff, we can whitelist them. So anytime we see an alert from ThreatWise, it's almost 100% a very high fidelity alert.
So the threats are put in, not in the data flow. So is it put in the backup environment or it's put in the production environment? And is the production environment on-prem, in cloud?
Good
like
question.
where is the production environment?
Yeah, great question. So the sensors go into the customer's environment, whether it's on-prem or in cloud, wherever their environment is. You could, and we're going to show this, we have a variety of sensor content that we have developed. So whether it's Linux machines or VMs or databases or firewalls, there's a wide variety out of the box that we support. So customers can put them in their real environments. It's not just in their backup environments, but as part, but a key innovation that we did as we brought ThreatWise into Metallic is we've introduced a backup sensor content as well. So we've introduced a Commvault backup server that looks and feels like a real data protection environment. And off late, we've seen a lot of these attacks also trying to figure out, hey, not only do I want to bring down the data and the production environments, but they're also actively looking for those backup, whether it's Commvault or some of the competitors, they're looking for those agents to bring them down as well. And this is where this additional sensor content that we introduce really helps. Any more questions before I move on?
Yeah.
Okay, great. And as I noted, we have these security ecosystem integrations out of the box. We support a variety of them, and the intent is, we are working together as an ecosystem to help protect customers' data. Right? We're not, there could be perimeter security defenses that customers have and other security tooling. We're not trying to replace any of them. This is an augmented signal that we're providing, right? Go ahead.
I just have a question. So what exactly is a sensor? Is it going to be like a little VM? Is it going to be like some sort of network tap or?
Yeah. Great question. So, the sensors, we have two types of sensors. One are what we call as our immolated sensors. These are really lightweight. You could have one virtual machine, but have hundreds of these sensors deployed on them, each with a different IP address. And the intent is, you're mimicking a lot of the responses that, typically a Linux machine or a database, you're mimicking those actions there, right? So when an attacker tries to interact with them, you're giving back them responses just like a real asset would, right? So these are very lightweight, easy to deploy, and that's one of the beauty of the technology, and where we differentiate with some of the other deception vendors out there, that customers can easily deploy and scale to hundreds of these sensors very quickly with these immolated sensors.
Will they run in containers or just virtual machines?
Yeah, they run on virtual machines.
Okay.
Containerization is in our roadmap. We're coming up with container sensors as well. And the second type of sensors is what we call as our full OS high interaction sensors. And this is like a complete stack. This is like a full machine that we install. And typically in a customer environment, we recommend hundreds of these emulations and maybe one or two of these full stack or full OS kind of sensors. Because the other, what the technology also allows is you could have these emulation sensors point to a real full OS sensor as well. That's where, customers, attackers, if they're trying to upload a payload, for example, they can try to upload a payload or a malware and in fact like a full OS system, right? If they're going through that process, then this is where, we point them to those, high interaction systems, sensors. And there's a third type of technology that we have developed, which we call as lures. And these lures are really like breadcrumbs. You can put them into my laptop, into any of the systems and endpoints and other machines. And these will again point, by themselves are not a trap or a sensor, but they will point, they act as a breadcrumb. If an attacker is trying to find, okay, where are some of the real assets that I need to go after? They can point them to our sensors instead of the real assets. So this again is a delay tactic while we are kind of flagging those attacks that are happening. Okay, and these, for all practical purposes, these look like real assets. There's no way for a threat to detect that this is not a real asset. And as soon as they even scan, as soon as even they do a simple scan, these alerts, in the back end, we're kind of, these alerts flare up, we're detecting those signals and sending them out. And as part of our, vision for this, we want to bring these data protection services and this ThreatWise service more closely together in future, wherein, we have, as Isabel mentioned, we have a machine learning engine, we have a correlation engine, and this will be another augmentation that brings in that high fidelity alert that we can quickly kind of then take action in terms of, hey, do we isolate the backup copies? Do we kind of, close the bridge and so on, right? But these are actions customers can take as well. Given the sensitivity of their data and the value of their data, and the sooner they can get those signals, we see tremendous value for customers, and it's been validated by our conversations that we're having with some early adopters with ThreatWise. So great.
You mentioned that one of the things Commvault did to add to TrapX was to provide like a data protection sensor or something like that.
Correct.
Is that a full OS high interaction type of sensor, or is it emulated sensor?
For bringing value to customers quickly, we have introduced it as an emulation sensor, so they can set it up real quickly.
And that would be, it could be set up in the cloud or on-prem, depending.
Yeah, it could be set up anywhere.
It kind of looks like a Commvault data protection solution.
Yeah, it looks like a Commvault backup agent.
Yeah.
Yep. So they're very lightweight, like we talked, with the emulation sensors, and they can scale quickly. With ThreatWise is a SaaS service, right? And the intent with launching it as a SaaS service was, how can we get value to customers as quickly as possible? And then our control plane and management interface is in the cloud. So it's in a separate security domain. So even if a customer's environment gets breached, their accounts are brought down, everything is brought down, you still have access to the cloud SaaS ThreatWise, so that they can kind of, even if it's for forensics or trying to investigate what happened, they have those data available.
So what sort of information do you provide the security ecosystem about the attack?
Yeah, so we're going to show that as part of the demo as well, but we're going to show where the source of this attack is coming from. So we can identify the IP address of whoever is interacting with us and indicate that. We can map it to like a MITRE ATT&CK framework. MITRE ATT&CK is a framework that has many steps in terms of like an attack comes in. Is it in lateral movement? Is it in recon? Is it trying to upload a payload and so on? So we can provide that information that, hey, we think this is a recon. They're still trying to figure out what's in your environment. We provide all the information around the interactions, like did they kind of request information? Did they try to do something? And you can also show that in a nice visual format. The visualization also kind of helps. And these are all prioritized. The important thing we talked about earlier is, there's so many events flooding a customer environment, right? From tools like data protection, from security tools. And all of these are coming in. But our events, we can prioritize them on criticality based on the interactions that we're seeing, that these probably are the most important critical ones that customers need to attend to first, right? And Luis is going to show this in the demo shortly.
So you did make the comment of there's no way to determine that these are not real production assets, but that it's also lightweight.
Yep.
I mean,
yeah,
they're going to show up one way or another.
You're absolutely right. So we mimic all the top typical interactions that a threat might, what is there and what is your, is there data in it? So we mimic the top 10 commands or so, or 15, 20, however many. But if they go deep enough, this is where the high interaction trap comes in, right? Sitting behind this emulation, we can have a high interaction trap. And these can actually point back. So when a threat comes in and is engaging with an emulation, and if there are commands that it's asking that's beyond what is in the emulation, then it can always kind of revert it back to this high interaction trap. But that's one way. And the other important thing is, as soon as they come in for that first interaction, even if they're scanning it, we're already flagging it in the backend. So they're already caught. Now, everything that they do beyond that is a bonus in terms of understanding what the hacker is trying to do, what are their intentions and so on. But it's already flagged. The alert's already gone. It's fired as a critical alert.
So just wondering off of that, because now you're expecting them to interact with something in an unusual way, which is what happens if they drop a rootkit and then 60, 90, whatever days later, then they start pressing and maybe are places they're not supposed to be getting more information. But are you able to detect the rootkit being dropped?
Yes, we detect that rootkit being dropped, but even before that, if you move back 60 days, the first time they're interacting, we're already kind of flagging that, hey, there's something that interacted with the system, right? Because any normal user, any real user should not be interacting with this sensor at all.
And so how many different types of sensors, emulated sensors, do you have? You mentioned data protection as one.
We have quite a few, and we'll show that in the demo out of the box. We have all the Linux systems, Windows systems, databases. We even have IoT devices. And an area where TrapX has really excelled is in customer environments that are kind of legacy environments, right? Where they could not deploy modern security tools as well. So, manufacturing plants, healthcare systems, printers. There's a wide gamut of devices that we support. And there's also a technology that we've built in, which is really cool, is bring your own trap. And what this does is if you point this to a device that we don't support out of the box, it can take some time to fingerprint it, right? It fingerprints the top, interactions, commands, responses. And then we can kind of build that sensor out. So that's pretty interesting as well. Some customers have used it.
Well, but I mean, I keep kind of coming back to how are you going to know that this isn't a real thing? This is like effectively a virtual appliance that you're deploying via a Commvault interface, right?
Right.
I mean, by the way that normally would work, by the time they would get to the point where they're discovering systems, they already, in theory, have cracked domain admin. And if you crack domain admin, you've cracked vSphere. And so are there no footprints to these appliances whatsoever that scream, hi, I'm from Metallic, I'm here to protect your data?
No, no, we don't advertise that way, right? So for example, think about an attack scenario. You got an email, I got an email on my system, a phishing attack, right? Which is one of the most common, like 80%, maybe Louis lived in the security industry all his life, can talk more about it, but you get a phishing email, you click on the link, something deposits on your laptop, right? From there, it starts kind of spreading its tentacles, trying to find out, how do I go to AD? How do I go here and so on, right? So this is where, our recommendation is we put in our lures, which are like breadcrumbs that can, instead of pointing you to real AD, we can even have like a fake AD setup as one of our sensors, right? So it points them to our sensor, which looks like an AD. And hey, lo and behold, in the meantime, in the background, we're alerting, we are sending those signals, not only to the data protection in our UI with ThreatWise, but these signals also go to the security ecosystem, wherever integrations they've enabled with Splunk or other monitoring systems. And, so there's all kinds of alerting that's going off.
So how confident are you this won't be hackable as well? Because it seems to me like, right, I drop a rootkit, maybe I don't drop a rootkit, I do a phishing campaign, and that gets me right in. Yeah. But usually phishing campaigns are going to go out, but that's another story. But like, it happens right away, and they find your lure. But like after doing that at one site, won't they? Isn't that seems like that'd be pretty easy to figure out that that's not really an asset.
So it's always a catch-up game, right? As some of us have seen. There's tools out there that are detecting, and then there are new attacks that try to leapfrog that and kind of hide themselves better. But the beauty of this technology is as soon as that first interaction happens, we're already alerting. So we have knowledge that, okay, this host or this machine is reaching out where it's not supposed to be reaching out. And from there on, they could potentially kind of, if there's, sophisticated zero-day attack like someone mentioned here, they could have the smarts to kind of try to outbeat the whatever security tools are in a customer's environment. But we've already flagged it. And the testimony to this is a lot of our most customers, they have these red teaming exercises or pen testing, right? For a lot of companies, this is a compliance need. They have to go through these exercises. If they have critical data, if they're in financial, they have to have these red teaming exercises to figure out where their vulnerabilities are. And as part of that, they're deliberately trying to do these kind of things that you talked about, where they're breaking the system. And we've seen time and again that our technology lights up in those scenarios.